Hello everybody, here's another snap circuit that I have constructed using various snap circuits. This circuit I call the electronic hand crank. Now, as you notice, there is some putty stuck to the hand crank because one time I was doing an experiment when I stuck something there and not all the putty was able to come off, so please excuse that. Anyway, the objective of this circuit is to see that the hand crank can use a motor to make itself spin, but it can also power an LED D1 at the same time. This circuit uses a battery pack B1, a slide switch S1, a red LED D1, a hand crank HC, and a high frequency integrated circuit U5. Also, why is the high frequency integrated circuit being used? The answer is because it wouldn't work properly without it. The LED D1 would just stay on all the time. You'll see in a second. So, when the slide switch S1 is turned on, electricity will start flowing through the circuit, and it will activate the hand crank, the LED, and the high frequency integrated circuit. So the hand crank is going to spin by itself, which is kind of creepy actually, and the red LED D1 will turn on. Sorry guys, I'm used to saying color LED because I use the color LED D8 a lot. So, the hand crank is actually going to be powering the LED D1 electrically. So, when I stop the hand crank with my hand, the LED D1 is going to turn off. And then, when I release the hand crank will start spinning again, and the LED D1 will turn on again. So, when the slide switch S1 is turned on, electricity starts from the batteries and flows through the slide switch. And it can either continue through the hand crank HC or down through the the red LED D1. So, when it goes through the red LED, it goes through the high frequency integrated circuit and back to the batteries. When it continues through the hand crank, it goes through this three. It doesn't go back through the LED D1 because, as you can see, the plus sign is right there and the arrow's facing the other direction. So it goes through the high frequency integrated circuit and back to the batteries. And that's where the electricity flows through the circuit. Also, why doesn't the electricity flow to this snap right here? The answer is it's not being used. So, here's specifically why the high frequency integrated circuit U5 is being used. When I stop the hand crank without the high frequency integrated circuit, the LED D1 will just stay on. So you need the high frequency integrated circuit in order for the circuit to work properly. So, this is what happens when you turn on the slide switch. The hand crank HC starts spinning, and the LED D1 lights up. As you can see, the LED D1 is kind of dim, because the hand crank is powering it. And hand crank power is not as powerful as battery pack power. So, you notice that the hand crank HC is spinning kind of slow. But why is this? The answer is the gears. The gear meshing is kind of special. They're kind of overlaid on top of each other, which makes one go slower than the other. So they have a ton of gears in there. There's 5 gears, and the smallest one, which is over here that you can't see, is going extremely fast. And this next gear is making the next gear go slower, which is making the next gear go slower, which is making the next gear go slower. So that's why the hand crank is going slow. Also, which gear is turning the hand crank? The answer is this one right here. But why? The answer is because it's right on the bottom of it. If I were to take the hand crank off, you would see the gear spinning and there would be a hole right there. So now I'm going to stop the hand crank with my hand, and the LED D1 turns off. And when I release the hand crank, the LED D1 turns back on. Now I don't suggest holding the hand crank HC for too long, because eventually it can burn out the motor. So that's not a good idea. So, now electricity is flowing through the circuit. But why can't you see the electricity flowing through the circuit? The answer is, all the snap wires have special coverings so you don't get electrocuted. Also, why is the electricity able to go through the circuit now? The answer is, the circuit in the slide switch S1 is closed, so the two wires can connect to each other, causing the electricity to flow through it completely. So it allows the electricity to be released into the circuit. So now we're going to turn the slide switch off to not waste the battery, or rather the circuit. So now the slide switch S1 is turned off, keeping the electricity in the battery pack B1. But why is this? The answer is, when the slide switch S1 is turned off, the wire makes a open circuit inside of the slide switch. So the first wire cannot get to the second wire, which is disconnected. So when the wire is disconnected, or the circuit is false, then the rest of the electricity is not able to go through the circuit. I hope I explained that clearly. Also, that's it. Thanks for watching. Also, please comment, subscribe, or rate. Peace.